Hello, I'm Philip Zimmerman, speaking to you from the classroom of the Phillips Museum. Today we are looking at what is called a chamber stick or candlestick, and I'm putting on my white gloves because the candlestick is made of metals and the white gloves protect the metals from any oils and anything else my fingers might put on them. As you can see, the candlestick has got a handle which allows one to carry it around conveniently. It's got a broad base which allows any drippings from a candle to be captured there rather than to fall on a tabletop. This chamber stick also has the unusual feature of a slide mechanism for the candlestick. The candlestick is held in a cup which is attached to this little handle, and by pivoting the handle into one of these slots I can keep the candlestick in place at these different heights so that as the candlestick burns down I push it up, and in that way I use the entire candlestick and don't have any wastage. If we turn it over, we'll see that the shaft simply screws into the bottom. I'm going to unscrew these so that we can see these a little better. And that leaves us with one part that was cast in a mold, second part which actually has several parts attached to it. We have a handle separately cast, and if you look carefully you'll see that there are some copper rivets holding that handle to the column, and then of course there is the candle slide that we talked about a moment ago. One of the things that we can see when we have this candlestick disassembled is the flat portion of this lower drip pan has got some concentric rings that are very visible. Those concentric rings are part of the cleanup process that the brass maker engaged in after he cast this part. The part was attached to a lathe and all the rough casting was cleaned off with a tool called a hook. Now this portion he left as it was after he had cleaned it on the lathe, whereas all the rest, which you can see, he further cleaned to remove those marks. Similarly, on the bottom of this you will see concentric rings that again are part of that skimming process. Now these are all evidences of pre-industrial manufacturing, 19th century and earlier manufacturing. Now if we put this back together again and compare it to another chamber stick also in the Phillips Museum collection, we see some interesting differences. Now this one looks very similar to the other, but when we turn this candlestick over, as we did our first one, we see that those concentric skimming rings are not present, and that's a telling detail. The newer candlestick that I added to the discussion is in fact a newer candlestick from the 20th century rather than the 19th century. Another difference is the attachment of the column to the basin. On the newer one includes not only a threaded shaft but a nut that secures that threaded shaft in place. No nut on the other example, a nut on this one. Now, this brings up the question about how much metal do you need to create a chamber stick. Metal in the 19th century, before some of the advances in metallurgy and extracting ores from the earth, metal was quite frankly an expensive ingredient of the object. The older one demonstrates some efficiencies in using metal. It simply has no more metal than is absolutely needed, whereas construction of the newer one includes extra metal. So that again is another feature of a newer object. So in summary, we can look at these two objects and see that they really are quite different. And these little details that we have outlined in this brief talk are the kinds of things that people who work with these materials all the time they use these little details so that they can right away say 19th century chamber stick, 20th century chamber stick. There's nothing magical about this. It's just a matter of getting to know what the form is, what the material is that it's made of, and how all that is put together. Thank you.